All right, so we just finished talking about the amazing thing about the central limit theorem and showing you that are some stipulations that have to occur for that sampling distribution to be distributed approximately normally. Okay, so here we go. Here are the things. What we need to do is we are going to get real. RIL. Now, when we write out these conditions and assumptions, which, yeah, sorry, but these are now going to become a very annoying and necessary part of problems from now on. We pretty much now all the time have to get real on every problem. Um, so, yikes. But anyway, we'll get over it and we'll get real. And now, when we do this, you need to write the words of what the R and the I and the L stand for. Do not just go RIL, check, check, check. No, that will not work. You have to indicate specifically what you are assuming or the conditions that have been met. Okay, so the first one is about random. The R stands for randomness. And what we want is that we want to state if our subjects were randomly selected, or if it's an experiment, we want to say that they were randomly assigned to the treatment group. And so by if it's just a study or then we want to have this random selection so that we're showing that they are representative. Okay, R is the random. Next, 2 is independent. So we know independent is important because we want to know that the probabilities from sample to sample have not changed. Okay, so this assumption is typically satisfied by noting that the sample we're going to take out is small enough that when you take that out, it's not changing the probabilities of what's left in the population. For example, here's my thing I like to kind of tell you to think about. So if you scoop a cup of M&Ms, so I want you to think of the M&Ms coming down the assembly line, okay, coming out of the factory. Say you and the proportion of them that are blue. Okay, so we know the proportion of them that are blue is about 20% if they came from Tennessee, Cleveland, Tennessee. So now take your cup, scoop it off that assembly line. Well, when you do that and you take out those 50 M&Ms, does that change the proportion of blue M&Ms that are coming off the assembly line so that that next cup that you scoop out is going to have a different proportion because of what you got in your scoop? No. And that is because the sample you took was small enough to not change the probabilities, even though you didn't replace it. Okay? Now, if you have replacement, then that's okay. Then that independence is taken care of. But see, look here. So mathematically, the way that is satisfied is we say that the sample size n is less than 10% of whatever the population is. So in our case, 50 M&Ms is less than 10% of all M&Ms. Heck yeah. Okay. Next. Now, here is where that what we just demonstrated comes into play. Our sample size needs to be large enough so that the central limit theorem will hold and we can count on our sampling distribution to be approximately normally distributed. So that sample size has to be large enough. And so the thing is that for means, n has to be greater than or equal to 30. Okay? So what's the exception to that? If it's not large enough, say you had a sample size of just say 10, then how could we still be okay? We could still be okay if it's back here. We could still be okay if that population had been stated to be normally distributed. Then a small sample is okay. All right. So back to this. Okay. So there we go. Then we conclude that the approximately normal model applies. I learned several years ago you don't say normal model applies. It's approximate because we never can guarantee that we have that perfect normal model, but it's approximately normal. So, in fact, the central limit theorem is what creates those three rules above. We've already talked about that. If n is large enough, then it does not matter the shape of the population. The sampling distribution is approximately normal. Now, proportions have a different large enough rule. The proportion sufficiently large is met in a different way than means. For means, it's n is greater than or equal to 30. But for proportions, you have to have at least 10 successes and at least 10 failures. So let me tell you something. That is why I personally had your sample size for your M&Ms be 50 because I knew in my mind 20% was that P. So look here, N times P has to be greater than or equal to 10. So whenever I concocted what we were doing with our lab, then I knew that I needed it to be this, that we were going to have that 50 times that 0.20. And guess what that 50 times that 0.20 is? Voila! So I picked 50 because I knew that was the smallest sample size that we could do to meet the criteria for proportion so that that sampling distribution would come out approximately normally distributed. Okay, now it's at least 10 successes and at least 10 failures. So in our case, so see for our M&Ms that we did a few days ago, we would say that we got that's greater than or equal to 10, but then we would also say that our 50 times the 0.80, which was 40, see, so that was also um, greater than or equal to 10. So our large enough for our proportions of blue M&Ms was met. Okay. So there is that. Now, let's take a look at this song, okay? Couple of things. This song says a couple of things, but I also want us to keep some things in mind because sometimes when I make these songs, not everything fits, or I learn some important things after I've already written the songs, but I just still go with them. Okay. So we want to know that the random is stated, or we're going to assume that it's representative of the population. So random stated or assumed to represent the population. Okay, remember we also want to say that it was randomly selected or randomly assigned if it's an experiment. Randomly selected or randomly assigned. I can't figure out how to get that to fit in the song right there. So I may have to just rewrite a whole song. Okay, independent. N is less than 10% of the population. Remember, your 50 has to be less than 10% so that it's not changing the probability of the blue M&Ms on the thing. Large enough is tricky because the large enough rule depends if it's a mean or a proportion. Mean has to be large enough, greater than or equal to 30. Proportion has to be greater than or equal to 10 successes or 10 failures. Okay, and then nearly normal model applies now. Nearly normal, approximately normal is what I always write. Approximately normal model applies. Okay. Now, this is actually really hard to see, but I want us to look real carefully at some common mistakes that are made that can just get you docked for conditions and assumptions. Okay. Do not write just RIL. You must write the words random, independent, large enough. When you verify the conditions or assumptions, you may not actually know that they are true. So that's why we will frequently refer to them as assumptions. Because think of it this way: you are stating the criteria that must hold for the distribution to behave approximately normally. So you may not know that 10 or 50 is less than 10% of all the students, those types of students or whatever, but you're saying if it is, then we're good to go. Rarely will you say that the conditions do not hold. Okay? Therefore, the normal model and the normal model doesn't apply. And this you're typically led down this road. You would see this happen only if you think the problem is leading you in this direction, such as a question like this: Is the shape of the distribution known? Or why is it not appropriate for you to conduct statistical analysis on the data? Well, that could be because there's a condition that is not met. Okay. And so in that case, you say clearly, okay? Now, if you are skeptical and you're concerned that a condition or an assumption may not hold, you can always make the statement about your concern, but then continue. Pretty much, unless you feel confident that the problem is leading you to state why it's wrong and you can't do the problem, then do the problem. All right, so you'd say something such as, I'm concerned that the sample size may not be less than 10% of the population, but if it was, then, or maybe then, then you continue and do the problem. Or maybe you would say, I'm concerned that the sample may not have been taken randomly and therefore may not be representative of the population. But if it was, then, and then you continue with the problem. Okay? So pretty much we're always going to don't stop the problem, don't stop believing that the conditions are met and all of that kind of stuff. So you know what? Let's do our conditions song. And then I'll probably have a third last problem. Here are random, stated, or assumed to represent. Here we go. Let's find that assumption song. I'll get off the screen here so that you don't have to watch me enjoying the song. I need to have the little goat pop up in this, and I've never gotten it in there. So here we go. Stated or assumed to represent the random, stated or assumed to represent the population independent. It is less than 10% of the population. Large enough is tricky because it all depends. Mean or proportion, mean is 30, proportion is 10. And the normal model applies now. Make sure you're saying nearly
and the normal model applies now.
Approximately normal model applies. Here it goes again.
Random, stated, or assumed to represent the population independent. It is less than 10% of the population. Large enough is tricky because it all depends. Mean or proportion, mean is 30, proportion is 10. And the normal model applies now. And the normal model applies now.
Okay. All right. So there is that. And I'll use those a lot of times as I'm going through the assumptions and going down those. Let's see. I don't want that to work to do that. So there we go. All right. So I think I'm going to stop the video right there because then I want to talk about this thing as one last component before we finish out.